Hi, welcome to another video on my Raspberry Pi 1 using fischertechnik motor and pulses modulation. Last time I tried to change the code I had and have for use with another DMA channel, DMA for direct memory access. And I tried to find out which pulse width, and that is this number, was suitable for a certain frequency. However, it turns out that 1999 is the highest pulse width, the largest pulse width, the widest pulse width that this program can use. Moreover, it also turned out that no matter what pulse width you use, I am not getting any other rotational speed, rotational velocity out of the motor. Since I use the power controller to test it, and the power controller is using 9 volts, my theory now is that when I use 9 volts and that enables pulse width modulation to adjust the velocity, rotational velocity, and under 9 volts that pulse width doesn't matter, at least not for a motor, not for this type of motor, and that you need adjustable voltage to change the velocity of a motor. Now, in the current situation, I don't have the potmeter into the circuit, so I am going to try to change that. Well, that will not be an attempt, but I have to reroute some of the wires. In the meantime, I am now talking about hard pulse width modulation. Soft pulse width modulation I did try before, because this is of course Python, and the soft pulse width modulation I used in C, and using that it does work, but on an LED in combination with resistors. So since my objective of this whole attempt is to get a motor, to control a motor using pulse width modulation, I'm afraid that this is not going to work with voltages lower than 9 volts. With this comes the fact that a Raspberry Pi is delivering voltages in only 2 voltages, 3.3 volts and 5 volts. Needless to say, 9 volts is no part of it. So does that indeed mean that my whole series of experiments so far is futile to get it working? Well, probably it depends on the type of motor I'm using, and if so, then I won't succeed. I'm not fully convinced yet, but so far it starts looking like that. What I can do now is, as said, rerouting the wires to get the potmeter into the circuit and see how that works out. And to that end I will change now the pulse width back to 50 and try once again. Does it work or doesn't it work? And right now nothing works, but that may be caused because of a wire. Yes, and when I take away the wire from the plus, it works. Alright. And it doesn't stop when I quit the program. So much for this short experiment. Up to rerouting the circuit. So the problem is now that, as I showed earlier, when I do this, then it works without it, and then I use pure pulse width modulation, it doesn't work at all. Point is then, how can I change this? Well, this circuit is using an op-amp, and I can regulate everything with this potmeter. Now this potmeter is still attached to this circuit. However, when I remove this one for now and I put the wire here, what happens then? Right now not much. What I need to do, I think, is putting just a wire here and another wire from here to there. So I am just removing another wire here. This is just a little experiment, of course. Moving it here. Still doesn't do anything. So I need a tool to change the potmeter. And let me just try this. And there you go. Now would this work as well when I remove this one and put the other one straight into it? That should work. So right now putting this one here. Try again, and the potmeter has to stay in socket. Yep, that works too. However, what you can notice is that within this range the motor doesn't do anything. And if you listen very carefully to the speed of the motor, it has a very, very small range in which I can regulate the speed. And you can also see that with this LED. And now the pulse width modulation program isn't even running. So what I want to try is to use the op amp to create a voltage, if possible, of 9 volts, and then use pulse width modulation. See if I can accomplish that, because this way I've tried enough and that is not working. So previously I used this circuit with soft pulse width modulation, which worked perfectly on the LED. So how do I accomplish that? Well, here I have the same thing of a transistor circuit, just like I did here. So I can use everything of this, not demolish this pulse width this op amp, and then I do have to measure the voltage and then see how things work out. So let's get to it. So as you can see, the whole circuit has been rewired. First of all, the motor has been placed from here to here. Also, the plus and minus wires, and let me adjust the camera in a little bit. The plus and minus wires, this plus and this one is the minus. Have been rerouted to here, plus and minus, and furthermore I have taken the op amp in use again. Plus and minus with a wire from the output here, then the motor to the minus and the motor to the plus. And the plus is here after the op amp. Then from here to the entrance, actually to the power of the op amp, and the output of the op amp to this LED. So now I turn the op amp on, and this whole track is it is off. And this is actually back to where I started. Also the same as with the soft pulse width modulation, except for the rewiring, but the idea is the same. Now the question is, how does it amplify? Because in theory an op amp, an operational amplifier, should amplify the voltage. So with the mouse probe here I measure the voltage, and then you see there's not much of a voltage, 2 volts, but that is alright because it has been turned down. So let's turn it up. Maximum. We measure again and we find it is about maximum 4 volts. So then we measure here. Close to 4.5 volts. So then you ask, okay, why is the voltage not higher? Because you have an op-amp. Well, it turns out that various op-amps have various purposes, and the op-amp I'm using, the 4560, is not the correct op-amp for amplifying the voltage. For that I should use the 471. So I have to find that one. Using that op-amp I might turn up the voltage to the desired 9 volts and then see if I can indeed get the hardware pulse width, the hard pulse width modulation to actually make sure that this motor is doing what it is supposed to do. And so far no luck. So this signal here, that is from the DMA pulse width modulation, has no use at the moment. So what can be done? Well, actually trying to incorporate this LED and see how this works out. So that is the next thing. Before extending the present state of the circuit to some LEDs, one or more, I want to go back to the code I used, because what I noticed, and that is fed by some confusion, I wondered, 17, was that opened at all? Because 17 is, as you can see here, GPIO, and that GPIO leads to confusion, because this pulse width modulation is not using GPIO, it is using RPIO. And if you see my previous video on this, not last one but one before, then it led to some confusion. And now here is GPIO, because this is real GPIO, pin 7, and GPIO 17 is not pin 7, it is pin 11. And when I looked at the software and I looked at the connector I'm using, well, actually the pin on the leading from the GPIO, I wondered, alright, how is this working? So then I added from GPIO 11 actually, yes, which then is GPIO 17, because, well, you still have to open it in my reasoning, but unfortunately that did not change anything. So whether or not you have to open GPIO prior to sending out or receiving some signal, this is still not working for me. And whether it be the like in the previous segment, not enough voltage, 5 against 9, or wrong use of the signal, wrong circuitry setup, whatever. The combined use of RPIO and GPIO is not really nice. So now I have done it totally without the use of pulse width modulation with the current circuit, and indeed the big question is, how do I combine everything? Usually the motor is supposed to run via transistor circuit. Right now it doesn't. I do want to use that, so that's one thing that I still want to accomplish, and then an LED somewhere in, but I want to use the this kind of pulse width modulation first on the LED. See how that works out, because I know from experience that it works on the soft PWM, pulse width modulation. Does it respond to hard as well? And that is what I try to find out, and therefore I need to have a loop as well somewhere, somehow, but I'll have to think about that first, because I'm not sure how to react, if it will react. So first things first, put the pulse modulation to an LED and see if it works out with this value. If not, I put it to the max value of 1999 and then we'll see. So back to hardware. So now the question is, with this current circuit, this part not really functional, not really with a point, because this could be leading to the motor, but it, as I've shown, not really much use. I could put the output to the motor, but what good would it do? So right now I'm taking out the pulse width modulation and I'm leading it straight to the LED. And then I should be able to see some light here. Let's invoke some light. Nothing at all. That could have to do with the low of the lowest pulse width modulation. So let me increase it to the maximum. And I change it to, let's say, a factor 20, which means 1000. And it doesn't do anything either. It doesn't do anything at all. or it is too fast blinking that I can see, or not blinking at all. Then next step is the maximum value 1999. Save, run, and once again not even a shimmer of light. So I guess that answers if it works on pulse width modulation. Answer is so far no. Then let's go back to this part, and I'm skipping these two resistors straight here. Then of course I can say let's put up the value. Then it is quite nice to see where this comes from. Oh yeah. So the positive I am putting first into the output of this one, being the output of the transistor, and it doesn't do anything. There's not even a shimmer of light on this LED. Then I'm putting it on the output of the op amp, and that kind of works. But not as fast. And now the question is, how much is the range? Because now the LED is off, but the motor is still running, and I didn't get that result when I had it straight on the op amp. So when I remove the motor now and put it back where it was, the motor isn't doing anything. But on here now it doesn't do anything. I turn it back. And it's still running. So that is a difference in behavior using the between using the op amp and not using the op amp. So there is a difference. And with this difference I'm not there yet. I have to change and replace the op amp to a different series, as I noticed before or mentioned before. When that is done, the pulse width modulation on this type of motor may come out or may not. What did I accomplish? A complete rewire of the circuit, reuse of the op amp, reuse of the potmeter, changing the code a little bit to avoid further confusion, hopefully. noticing that software or soft pulse width modulation works on the LED, hard pulse width modulation doesn't. At least not that I have noticed. Where will this go on? There is a distinct difference in my experiment with the Arduino and with this Raspberry Pi 1. Using the Arduino, I cannot use a motor without a transistor. Well, maybe I can, but so far no luck. Here I can use it. Why is the difference? Can't tell. I don't know. But with this new setup, who knows what comes along. So for now, thank you for watching. Been an interesting experience again. If you like my videos and haven't subscribed yet, please do so. See also my Instagram. If you like my videos and think, okay, I might donate, please see my website to keep the blog alive with the videos. And this is certainly to be continued. So, bye bye.